Good morning, everyone, and welcome to today's webinar on SolidWorks Mbd, that is Model-Based Definition. I'm Prithvi KV, Application Engineer at Beacon, and I handle SolidWorks CAD and the technical documentation products. Before going into today's webinar and seeing the capabilities of SolidWorks Mbd, let us understand what is the traditional process that we follow in the manufacturing process. So first we normally design the model in CAD, then create a detailed 2D drawings, and then these drawings are released to the manufacturing plants or the production plants. Apparently, if you see, the 2D drawings require almost 30 to 40% of the time and cost of the entire production plan, including your design, creating drawings, and the manufacturing cost of a product. And there are a few challenges which are persistent even today in terms of creating 2D drawings and maintaining them. A few of them are like it requires a very highly skilled person to read the 2D drawings is one thing, but the first and foremost is the time what is required to create the quality and impart the clarity in these drawings is very huge. So normally there is confusion for a person even when reading a drawing with too many dimensions. Basically, it will be all in 2D, so it will put many confusions into the person who is reading it. So to come across the challenges in 2D drawings and also to minimize the cost and time required to create the 2D drawings and maintaining them, we have a wonderful solution in SolidWorks called SolidWorks Mbd, that is Model-Based Definition. Let us go ahead and see what is model-based definition. Let us start with an example. So as you can see, this is a finished part that I want to obtain. But to obtain this part, to achieve this part, the first thing what we do is we design in the CAD. Then if there are any stages for achieving this part, we create the design for those stages and the drawings for these stages. The drawing includes high quality information, and we also have to provide the section views, detail views, and all other information that is required for the production to run smoothly, right? So the time consumed to create this drawing is on the higher side, and also to maintain these drawings and basically the revisions. Every part will have so many revisions, and to maintain these revisions, it will take more. It will consume more human effort and as well as the cost. But in SolidWorks, we have a wonderful solution called SolidWorks Mbd. SolidWorks Mbd or model-based definition is a drawingless manufacturing technique used. SolidWorks Mbd helps us to go paperless and add all the information onto the model directly, that is a 3D model, and eliminate the 2D drawings or the need of 2D drawings in an organization. So let us see what SolidWorks Mbd is, and before that, SolidWorks Mbd greatly facilitates and the compliance with all the standards like military standards, ASME, ISO, and DIN. So every standard is complied with by SolidWorks Mbd, that is model-based definition. So let us see what SolidWorks Mbd is, and let us go into the tool and dig deeper. That is, understand what it can do and the capabilities of SolidWorks Mbd, and how we can circulate the design or the design among the organization or even to the production team. Let us take an example of one of the parts, that is the gear plate, and let us create the document. So the base for MBD is we have to have the DIM expert, and everything will be recorded through the DIM expert, and we can add more information onto our models. So let us start adding the model. Let us start adding the product manufacturing information onto this particular model. So this is called the view palette in SolidWorks Mbd, where all the views will be captured and all the changes will be captured, whatever we are going to do it. So let us start with the auto dimension scheme. And before that, we normally use in 2D drawings, we normally add nodes and the tolerances, the global tolerances. Basically, if it is not specified to every dimension, we add these nodes. We can customize these nodes and also add it as a library feature where we can just drag and drop it onto our screen, and this will be replicated onto the model. So we can also add these nodes, and it can also be added to our design library. So this will minimize our time while adding the nodes, and this can also be made very smart by linking the material and the mass properties to the part, and whenever the mass or the material changes, this will also update automatically. You can just update the preview. So let us start adding few information onto our part. So we have, as I told, we have a very beautiful thing called auto dimension scheme. What this auto dimension scheme does is it will automatically capture all the dimensions that is required for us onto the model. Let us start with one of the examples. So here we have the option to select the type of part, where we can select a prismatic part or a turned part. For this part, I'll keep it as prismatic. And we can also select the tolerance type based on the requirement. It may be plus and minus tolerances or the geometric tolerances. And if there are any patterns, we can add linear patterns or the polar patterns. The basic or the very foremost thing what we have to do is we have to just select the primary data, the datums, or specify the datums. We'll go ahead and do it. So this bracket has to, this will be mounted on a bracket. So this is a mounting face. So I'll just select this as a primary datum, and the secondary datum is this shaft hole, and the tertiary datum is this particular compound hole. This being a compound hole, this was created, or this will be machined in a single operation. So we have an option wherein we can create a compound hole in a single click, and this will take it as a compound hole or a single feature for us, and it will be very easy for us to define it. And we can select all features or the features that are required to be dimensioned, and I can just click OK. SolidWorks will do all the hard work for us, bringing all the information onto our screen. So this is simple inside SolidWorks, and this is similar to the feature manager tree. What we have, we can just change the tree display to the annotation based. So the importance of this tree is whenever I select any datum or any feature or any dimension for that matter, it will cross highlight. So this will make me understand much better what the design is and how the design is coming together, and I can make any changes pertaining to pertaining to the designs. And as you can see here, the part which was defined has turned into green. So green color indicates that it is completely constrained or fully defined feature. So we can just move on to that. So, we also have other color coding such as yellow, which defines or which indicates that it is partially defined, and we can go ahead and fully define by adding more annotations or more dimensions to it. So let us start capturing from the top view of the model, and we already have the hole dimensions for these two particular holes, but the requirement comes such that we have to also have to define the position of these two holes, right? So let us go ahead and do it. In SolidWorks MBD, we have a very good option wherein we can recreate the basic dimensions. As you can see, in a single click, I could recreate the position dimensions for these two holes. So this is easy inside SolidWorks MBD to do it. And these are the two dimensions which I want in the top view. Basically, these are also the hole dimensions, or defining the position of those holes. If I want to just select and move it to the top view, this is easy to move the annotations or move the GD&Ts that we have created onto the view that we want. So we'll just orient the view. All I have to do is I have to just select, take few dimensions, and just reorient or organize them. And now the top view is ready for us to capture, and I can just capture it as a view. Here I have the option wherein I can select which are the views that I want to include in one particular view or the annotation views, So basically, I can just select which are the views. So I can eliminate the note areas, left and the back views. I just need only the top view, and I have the option wherein I can select the configuration that I require. So the top view is already in place. Let us go ahead and define few more views that are required for the manufacturing to be completed, or my document to be completed. So let us again start. Let us take the front view and define few parameters. As you can see here, there is a pattern on this particular face. So we have to dimension the pattern features. For this, normally what we do is we do manually, we add the angles manually. But here in the auto dimension scheme, we can, by using the auto dimension scheme, we can directly do it, and it will be completely automatic. So I can select the plus and minus tolerance here. All I have to do is I have to just select the primary datum, and the features, I just select this particular hole. So as you can see, if I said just select one particular hole, SolidWorks is already taking it as a pattern and recognizing it as the pattern. So now we'll have all the complete details of the pattern. So this is this easy inside SolidWorks Mbd to dimension your parts or dimension your features with respect to your model. And I can just capture this as a front view. And let us move on to the right view. So we just saw about the auto dimension scheme that we have inside SolidWorks Mbd, but let us see how easily and quickly we can do it in the manual dimensioning schemes. So if we are doing anything manually, we can do it very easily as well. So I'll go ahead and define. So as you can see here, this particular boss is intersecting with this plane, but while dimensioning, this plane has to be together. So I can just create a compound plane wherein it will take these two faces and create it as a single plane for us, and it will make it easy for us to add the dimensions. So while adding the dimensions, I can just select what is the type of tolerance that I want. So it may be a bilateral or limit tolerance or anything for that matter. So it will change accordingly, and we can add a few more dimensions here. This face to this face, and the thickness of this particular part. And the height of this model. So this is how quickly we can add the annotations or add the dimensions for the part. And moving on, we have to measure, or we have to add the dimension between these this fillet and this fillet. But the requirement is such that we cannot add it from the face, but we have to add from the intersection of the fillet region or the fillet face. For that, we can add the dimension by using the location dimension. What we have is we can create an intersection line directly. This is this simple. I can just select the face and create an intersection line, and SolidWorks Mbd will create that junction or the intersection line wherein I can place my dimension. And once we are done, we'll have the option to place the dimension in horizontal or vertical directions, or to user created planes for based on the requirements. For now, let us leave it as a vertical dimension. And capture this particular view as well. So this easy to capture even the tiniest details or even the complex details that we will normally take time to do. If we had to capture the distance between these two fillets in a 2D drawing, we would have had to create a separate construction line for those fillets, and then we would have added the dimension between those two fillets. But here it is very simple. It happens in a few clicks, as you can witness. So moving on, we'll just create one more view, that is the left view. So normally while creating a part, the user would have given information, a few information such as so basic dimensions or the feature dimensions. We can directly leverage those informations what we have given during our model creation. We can directly leverage that, and I can just, as you can see, these are the information that I had given while creating this part. So I can just directly leverage or use this to my document creation. I can just select what are the dimensions required, and I can just flip it out as we did earlier. So this easy inside SolidWorks Mbd to create or leverage even the used or the given data from the earlier stage of your design. So I can just capture this particular view here, and I can add what are the information that I require. So normally, even while creating a 2D drawing, we take a lot of time to create the section views or even the detailed views. And it also depends on the imagination of the designer, how he positions the section plane or even the detail plane. But in SolidWorks Mbd, we can directly do it onto the 3D model, and taking a section inside SolidWorks Mbd is very easy. As we do it inside SolidWorks, we just take a section plane here, and I can just hide these annotations. Can hide these annotations, and I can orient them. Now I'll just take another section plane. Now I can have taken a section plane, and I can directly add the dimension for this particular hole. Now SolidWorks is automatically taking the dimension for this particular hole, and it is also recognizing the holes with the similar holes present in the model. So because of that, you can see that the 8 into the dimension of the holes. There are 8 holes that has been recognized, and it has been automatically taken. We can also add the geometric tolerances. And we can specify the planes. And we can specify the planes as well. So this easy inside SolidWorks to create a dimension or create a whole dimension inside SolidWorks Mbd. So we know about SolidWorks configuration tool inside SolidWorks. So this is a very helpful tool in creating different designs or even the stage-wise drawings what we create. So basically, if we have to create a stage-wise drawings, we create this we can use the configuration tab, wherein we can create a stage-wise drawings and create a separate drawing for each stage. And also one more usage is for the design automation. You can build your designs in different sizes or build your parts in different sizes by using the configuration tool, which is again an Excel based tool. Here I have a few configurations of the same part. Now if we have to create a drawing for the configurations, it is not possible in 2D. So we have to create a separate drawing for each and every configuration. So that again adds up to the time, and it is again a laborious process. But inside SolidWorks Mbd, we can just select any version or any model that we have created, and we have something called as copy scheme. So this is a very brilliant tool wherein I can just copy the complete information that I've given onto my default model onto my configuration or the new version that I've created. So this is this easy inside SolidWorks to do it. So let us go to the top view and see what are the changes that has happened to the model. And as you can see, all the information from the default model has been leveraged into my into the newer configuration, and I have not done anything other than copying the scheme completely. So this is this easy to create different drawings for different versions, and I will just capture this with the help of the capture tool, and I can add all the information that I require, and it will work. So I can just change the name as version 2, and this is done. So I have a quick question for everyone. Before we go ahead and publish and see what are the capabilities of publishing inside SolidWorks. So I'll wait just for 5 more seconds. Yes. Thank you. We have got a good response. Around 65% of the audiences have voted yes for using eDrawings. It is a brilliant tool wherein you can share your designs or communicate your designs very easily and very effectively as well. In SolidWorks MBD, we have a brilliant option wherein we can export the product and manufacturing information, and also the complete detailing what we have added onto the model in terms of 3D PDF as well as e-drawing. We have a template editor. Basically, in 2D drawings, we go for the templates to capture our industrial standards. Similarly, we have a wonderful template editor that works very efficiently. So this is one of the template editors, or this is one of the templates we can add. We can customize the templates according to our requirement. We can add the bill of materials in case of assemblies, and the notes will be automatically taken. We can also link the custom properties as we do in our 2D drawings. We can completely link the custom properties. And now in 2018, we have also got an enhancement where we can link the custom properties of every configuration. So whenever we change a configuration in 3D PDF, while looking into it, even the custom properties will be changed, may it be the material, weight, or any custom property or any property that we have added. So moving forward, let us just publish this to a 3D PDF and see how we can leverage the information. I can just select all the views or only the views that I require to be published. And talking about the custom properties, here I can just select what are the custom properties that I require, that are required, and I can link. So I can just use this information and I can link to my 3D PDF. So I can just save it. I have already created one document. So this is one of this is the PDF, the 3D PDF what we have created. As you can see, the notes are already in place, and all the information, all the tabs, all the views are already in place. I can just select whichever view I want, and this is completely 3D. And normally what happens in 2D drawings is the person looking into 2D drawings might get confused if there are many dimensions. Basically, if there are many linear dimensions that has been given, so he'll not know from where it is starting and where it has to end. So these kind of confusions will be there. But inside SolidWorks, there is an option where we can cross highlight. So whenever I select a dimension or a feature, it will cross highlight from which plane to which plane is the dimension applicable. So this will reduce the burden on the person also who is reading the design or reading the drawings. And you can just select and make sure what is the dimension that is selecting. And as you can see here, so whenever I just select it will cross highlight the feature, so I can just be secured of what I'm seeing and what has to be done. I can just change the tabs, the views. I can select any view, and I can also inspect. So again, in 3D PDF, we have a set of tools where we can check the dimensions, basically for linear dimension, the measure. If any dimension is not added, we can also measure the dimensions, and we can make sure everything is proper. So we can also publish it to 2D drawings. We can also publish it to eDrawings, and it can be communicated. And from now, we have in 2018, we have also introduced in eDrawings, we can also add the step file attachments, and this can also be communicated to inside the organization or even to the vendors or the suppliers. And as we are going into the industrial 4.0 revolution 4.0, everything is being very intelligent, being made very intelligent. So nowadays the CNC machines also take they no more need the 2D drawings to be added and the coordinates to be mentioned. They can directly take the 3D, they can directly read the 3D model along with the PMI. That is the step 2425. We can also now in SolidWorks Mbd, we can export it to step 242 with all the product and manufacturing information, that is the PMI added onto the model. So this is also one of the biggest advantages wherein we can leverage the complete uh, ecosystem of SolidWorks, and we can speed up the process of manufacturing as well. I also have an example for an assembly PDF. So as you can see here, this is a part, this is a complete assembly, and this is a gear plate. So the bill of material is also already here. I can just select the bill of material, and the cross highlighting also works. So whenever I select any part, I can just make sure what the part is inside a bill of material and what is the corresponding part in the assembly. So this will also be better in terms of communication, and we'll have a better and clear picture for us. So you might be wondering from where the dimension tolerances or the tolerances what we are taking, for example, these tolerances, where it is coming from. So this is document properties. We have already set a few tolerances. This can be again customized according to the requirement. So for every parameter, there are tolerances that can be specified. So this can be customized according to the requirement, and this is global settings, but we can also set the tolerances locally. So whenever I want to do it, I can just select it, and I can change it here to only that particular dimension. I can change it, and it works. So now in 2018, we can also, one of the biggest enhancements in terms of model-based definition is for 2D drawings, we normally create a 2D drawing, complete the 2D drawing, then we create a ballooning for the same, and then also then create a report, the Excel report, the inspection report basically, to help the quality team. But in SolidWorks, we can do everything in a single window. So now I have just created this particular this particular information onto the model. If I want to just capture it, I can just go on and capture the balloons. So everything can be automated inside the SolidWorks ecosystem, and SolidWorks inspection will take all the information and completely balloon the models for us, and which can be exported into SolidWorks inspection reports. As you can see, this is this quick and easy for us to define the balloonings and also create the inspection reports. So I can just export it to the Excel or a 2D PDF or a 3D PDF. Again, I can export this information to the 3D PDF, and it can also be completely visualized in the 3D environment. I can also export the report, the first article inspection report, into eDrawings. So this is how quickly and easily you can leverage or create an inspection report out of the model after even adding the product and manufacturing information onto the model directly with the help of MBD. So this is the biggest advantage of SolidWorks. Everything is in a single platform and everything is very parametric or associative. So any changes in the model will reflect into your model-based definition or the product manufacturing information that you have added, and also the inspection report. So there is no need for you to create separate reports or create separate instances when you have to go and change the information that you have added or modified. So this was SolidWorks MBD as a brief. If you want more information, you can just mail us. And the typical manufacturing process, we saw the typical manufacturing process and what is the disadvantages or what are the challenges what we face when creating the 2D drawings, right? So what we propose in SolidWorks MBD, that is a model-based definition, is we can eliminate the drawings, we can eliminate the time and cost involved in creating the 2D drawings, detailing them, and also maintaining them is eliminated, and we can go paperless and contribute something to our earth. So what we offer in terms of SolidWorks MBD is we can directly add the information, the PMI onto the model, and we can organize them. We can have all the views similar to the 2D drawings with more and greater clarity in terms of your section views, detail views, or even the views that are required for the manufacturing. And finally we can publish it to the n number of ways, as you saw that we can do it for a PDF, we can do it for eDrawing or step 242 as well. So this will also lessen or gives more clarity for the person who is reading the drawing. So in a nutshell, I would like to summarize what we have seen until now. So inside SolidWorks or MBD, we can define and organize the PMI directly onto the 3D model, where we can eliminate the time and cost of creating the 2D drawing and maintaining it. We can publish it in terms of 3D PDF and eDrawings, and export to step 242 along with the complete PMI. This is very useful for the model-based machining. As I told, nowadays CNCs are directly taking the models, the 3D models, and understanding the PMIs, the tolerances, and it can be machined within no time. And we can compare the two 3D PMIs and study the changes. Basically, when we are having the revisions or different versions of two components, we can directly compare the 3D PMI in SolidWorks MBD, and we can have a check on what are the modified changes, what are the changes that have been added onto the model. And as we saw, we can directly create an inspection report automatically for the PMI, for the entire PMI within no time. So this will save a lot of time and lot of effort of the users and the engineers working on the models day to day.